Let's continue graphing square roots. When you graph a square root, you can actually reflect it two different ways. The first is across the x-axis, and the second is across the y-axis. This purple graph here is our parent function, represented with the equation f of x equals the square root of x. The red graph is represented by the red function, f of x equals negative square root of x. Notice that negative in front, that represents our a value. When we have a negative a value, it reflects the graph down. So, for this function, you would have a domain of 0 to infinity, but you would have a range of negative infinity to 0. The green graph is where the b comes into place. When you put the negative underneath the square root, what this means is multiply your input by -1 first, and then take the square root. Well, because you can only take the square root of numbers that are positive, we can only use negative numbers in this function. Because if I multiply a number by -1 first, it will become positive and I can take the square root. Let's look at the domain and range of this graph here. The domain, the x values, are from negative infinity to 0, but your range would be from 0 to infinity. So let's practice graphing a couple of functions, a couple of square root functions that will reflect across the y-axis. So let's look at this example here. We're still using the exact same parent, so I'm going to go ahead and quickly create our parent table using perfect squares so we can avoid decimals. This is the b value. B transforms x. Everything underneath the square root affects your domain. Everything outside of the square root changes your range. In the past, we've only had h, but now we are adding in one more, and that is your b value. In this equation, in this function, b is -1. And because b is -1, it is going to cause the second function to reflect across the y-axis. So we are expecting to see a graph that is reflected across the y-axis. In this example, h is 0, but my k value is 5. And because k is 5, it is going to move up 5. So this is our first function where we are actually multiplying our domain. We need to multiply our domain by b. So all of our x values will be multiplied by -1. So let's do that. Let's multiply our x values by -1. And we get 0, -1, -4, and -9. This function has an a value of 1 and a k value of 5. So I'm multiplying all of my y values by 1, which is not going to affect it, but I also need to add k, which is 5. So let's add our 5 all the way down. And when we do, our new y values are 5, 6, 7, and 8. So I'm going to graph the parent just as a comparison point. So this is where we began with our parent function. And now when we graph our transformation, let's see what that is going to look like here. So this graph starts at 0, goes up 5, and then at -1 it goes up 6. At -4 it's up to 7, and at -9, we're going to go up to the 8. Okay, so this graph, instead of moving to the right, it is coming from the left. This is our transform function. This is what this graph is going to look like. If you have a hard time determining your domain and range, look at your table. Where do you begin and what's happening after that? So this started at 0 and all the numbers are less than 0. So my domain is x is less than or equal to 0. But again, in interval notation, we always begin with the smallest number. So whenever it's less than, we begin with -infinity. Never put a bracket on infinity. So our domain is -infinity to 0. Our range begins at 5, and all the other numbers are greater than 5. So our range is y is greater than or equal to 5. So that would be from 5 to infinity. Let's do one more example. Okay, so now let's look at this one last example where we have a b value of -1. Now, b, because it's underneath the square root, directly affects h. So whenever h is not 0, and this is really important, when h is not 0, we need to factor out the b in order to figure out what h is. Notice how this is written. This is written with b factored out. So we have to factor out -1. And when I divide both of these by -1, I have -1, and that's multiplied by x plus 4. Okay, so this is how we need to write it in order to graph it and find our transformations. So again, our b value is -1, and because b equals -1, it is going to reflect across the y-axis. Now let's look at our h. H is actually -4 because I'm looking at this x plus 4, but it's still the opposite. So it's the opposite of +4, which is a -4. So it's also going to move to the left 4. So again, I like to put down my parent table. This is where we're going to start. And now we're ready to do our transformations. So we have two transformations that are happening to x. We have to multiply them by -1 and then add -4. Remember, order of operations, we always multiply before we add. So our x values, we're going to multiply them all by -1. And then after we do that, we're going to add the -4. And we're going to do this all the way down to our domain to get our new domain. In this example, a is +1 and k is 0. So there won't be a change in our y value. So our y value is going to stay 0, 1, 2, and 3. So now let's find our new domain. So I have 0 times -1, which is 0, and 0 plus -4 is -4. 1 times -1 is -1. -1 plus -4 is -5. 4 times -1 is -4, and -4 plus -4 is -8. And our last point is -13. So now we are ready to graph. So this graph will begin at -4, 0. And then we're going to go to -5, +1, and -8 up 2. My graph is not quite large enough to fit that last point, but that's okay. That is what my graph looks like. And I will go ahead and put the parent down just as a comparison. And as you can see, if you look at the red graph and the black graph, you can see that this graph is reflecting across the y-axis. It's going the opposite direction, and it also moved to the left 4. So what would be our domain and range? So here, if I look at my table, I start at -4 and all the other numbers are less than -4. So my domain would be x is less than and equal to -4. In order to write that in interval notation, I would write -infinity to -4 with a bracket. My range is 0, begins at 0, and it increases. So its y is greater than or equal to 0. So bracket on the 0 going towards infinity.